is the square root of x minus 3. And then let's do a table. We'll get to the table in a moment. Yeah, let me get to the table. Okay, x and h of x. So let's go -1, 0, 1, 2, and 3. I'm just gonna use the same values and hopefully it all works out. Okay. So the first thing I want us to do is to find the domain and range of each of these individually. I guess just the domain. You're just doing domain, it looks like. Is that right?
Yeah.
Just domain. Okay. So let me kind of reorganize these and we'll look at them differently. Actually, let me not do that. Let me grab snip because we're gonna use these in part 2. So let me just grab a snip. All right, I've done that. Okay, f of x. F of x. What is the domain of a quadratic? Does it have any restrictions at all?
No.
No restrictions. So its domain is all real numbers.
Okay. Got it.
Okay, now g of x, this one you have to set the inside part greater than or equal to 0. You have to set the inside greater than or equal to 0. So you have to literally set x minus 3 greater than or equal to 0.
Okay. So it would be x is greater than or equal to 3.
Yes, but you know that your instructor is expecting something slightly different. They're expecting the curly braces, x such that x is an element of the real numbers, comma, x is greater than or equal to 3.
Okay. I got that part.
Okay, so that's it for that. Now, how about for h of x? And it comes from the table. So what are the x values? And it's literally just the x values.
Oh yeah, it's -1, 0, 1, 2, 3.
Yes, -1, 0, 1, 2, and 3. It's just whatever the x values are.
Okay.
Okay. So that's important. That's not, there's no questions yet that we've answered that are going to be on your quiz, but or retake, but you got to know the domain because it will come in handy for the next part. Okay, so I'm going to scroll down here. I'm going to paste in these functions and we're going to find h of f of 2. So which do you do first, h or f?
F.
F of 2. So you got to first find f of 2. Which function are you going to use? Well, the one that says f. So that's 2 squared minus 4. What does that equal?
Oh, it would equal 0.
Okay, so now you take the result, that's 0, okay, and you use that in h. So now you find h of 0. So you look for 0 on the left side of the table. And then what is the right side value?
3.
3.
Okay.
Anything on that that's like unclear?
No, it's a lot more clear.
Yeah, it always is the second time around. You're like, why didn't I get this the first time? All right, so g of h of, so I didn't come up with a good number here, but that's okay. Let's go g of h of 0. Yeah, we'll have to do that. Actually, let me add a point here. I don't want to do that. Let me add a point here. Let's see where I'm going with this. Okay, G of H of 4. Okay, so again, which do you do first?
You do H.
Okay, so H of 4 equals
7.
7. And then you use that value in G. So it's the square root of 7 minus 3.
So it would be 4.
Square root of 4.
2.
Yes.
Okay.
All right, so next question. We want to do F plus G of 4. F plus G of 4. So this one's kind of unrelated to the previous two. This is not composition. This is figuring out F of 4 and then adding to it G of 4. So you just go to the function, find F of 4, go to the other function for G, find G of 4.
So it would be 5 and square root of 2.
So you're putting 4 in for X, right?
Yeah.
Both cases. So it's F of 4 means 4 squared minus 4.
Oh, I
16.
did minus 3.
Okay. And then G of 4, same thing. It's the square root of 4 minus 3.
Okay. Oh, so it would be 1.
It'd be 1. Yep. Square root of 1 is 1. And so you add those together.
It would be 13.
13. Let's try another one here. Let's make it slightly different. There's a lot of variations on this question, so I obviously can't do them all for you, but let's do H minus G of 3.
So it would be negative 2.
Yes, H of 3 minus G of 3 is negative 2 minus 0. Perfect, you got it. Yeah, you're much more confident in this, which is great. I mean, that's the idea. We just got to figure out how to get you, confident the first time around for your other tests. So the next question here is to find the equation for F over G of X. And you literally just write whatever F is over G, whatever G is, which is not G, it's X minus 3. So if G were on top, G goes on top. If F were on the bottom, whatever order it's in, you do that. Now the domain Domain is just slightly more complicated for this. We've talked about setting the inside part of the square root greater than or equal to 0. The problem
Mhm.
is that it cannot equal 0 because you cannot divide by 0. You can never divide by 0 on the bottom. So you set it actually to just greater than 0. Because if you let it equal 0, then it could be 0 on the bottom.
Okay. So it would just be x is greater than 3.
Yeah, but you got to do it with all the bells and whistles, right? The curly braces, all these symbols like this. Yeah.
Okay.
But um, E was really awkward when we did this. Let me see. I think let me look. F of G. Okay, actually we can do that. Okay. I'm trying to get in the mind of your instructor and figure out what the heck they were thinking when they gave you these questions. So it's a bit of a, I don't want to do that. All right. So the next thing that you might be asked for is a composition of these functions, which you might think, okay, we've already done that. Let's go back and look. We kind of did, but we did it with numbers. Okay. And numbers are easier. They're preferred.
Right.
All right. So here's what you do. You start with G of X and you put it in for the other X. Okay. So wherever you see an X, you put in the square root of X minus 3.
Okay.
Okay. So when you square a square root, you get X minus 3 minus 4. And then that becomes X minus 7. Okay. And you're like, okay, I'm done. But it also asks for the domain. And this is one of those like trick questions, so to speak. So you actually have to go back to the original, all the way back to the beginning of our lesson. Remember how we talked about the domain of each of these of F and G?
Yeah.
F was everything, but G was not. It was more restrictive.
Yeah.
So you can't look at the end result. You have to look at what you started with. And whichever one is more restrictive, that's the one you're going to use. So your domain is the G of X domain, the square root one, X
Oh,
such that X is an element of the real numbers, comma, X greater than 3. It's a little nuance,
yeah.
but it's like, it's just, you got to like remember this in the heat of the test, quiz. I mean, I wouldn't beat yourself up if you didn't remember it, but that's yeah.
Yeah.
So the issue is that when you get to X minus 7, you might think the domain of this is all real numbers, but it is, it's just, but it's where did it come from? Where did it come from? And where it came from is has a more restrictive domain.
Right.
All right, so let's go to the other side here of the page. I think this was some sort of transformation problem.
Yeah.
Oh, amplitude problem. Okay. Oh, goodness. Okay. Yeah, I remember we did this, and it's just so out of context. But we'll go through it. So let's look at the parent function y equals sine x. There are 5 points that you need to know. Okay, and I think it's actually easier to start with the graph and do some visuals on this. So it starts at 0, 0, and it trends up, and then it trends back down, and then it trends down, and then it comes back up. And this is considered one period because it returns back to where it started. You're going to San Diego, the waves, they do this, up and down, up and down. All right, so we need some of these points. So 0, 0 is the first point. This next point is at what's called pi over 2, comma 1. Then pi 0. And usually this isn't taught until trig, so I don't know why you're learning it here, but you are, so I can't do anything about it. 3 pi over 2 is -1, that's right here. And then at 2 pi, it returns back to 0.
Okay.
So you got to know this. And then the thing is there's also cosine, which I don't know if you will get. Do you happen to know if you're going to get a cosine graph?
I don't know.
Yeah. Any way to find out? Phone a friend.
I can.
Okay. Well, if you ever can get that information, that does help us here. I'll just go off a sine and hopefully you get a sine. Okay.
Mhm.
So the transformation is 2f 1/3 x minus pi minus 1. And it asks you a lot of questions about this. It's really the following. It's really now 2 sine 1/3 x minus pi minus 1. That's how you're supposed to interpret these things. Like basically instead of f, it becomes sine.
Okay.
All right, so there's a bunch of questions here. So the amplitude, and we'll try and do this generally. The amplitude is the number in front. But there's an exception. If it's negative, it's just the number without the sign that's in front.
So if it was negative, it would be 1/3.
No, if it was -2, the amplitude is 2.
Oh, okay.
Or if it's -3, it's 3. But it's the number in front.
Got it.
All right, so now the next one it asks for is the period. The period is 2 pi over b, and b is this number in front of x.
Okay.
So in your case, it's 2 pi over 1/3.
So it would be 6 pi, or would it be 2
Yes,
pi?
yes, 6 pi.
Okay.
You said it perfectly. And it's really yeah, it's really important to like get that get that down, because it's you will get something like that on the test, I'm sure. Sorry, give me just a moment here.
Oh, you're good.
Dealing with something. I know this isn't super exciting either. I really, all right. So the next thing it asks for is the phase shift. The phase shift is actually this thing inside parentheses with the X. Let's see if I can get right there. So you would say it's pi right. Okay, and it's right because of the same reason that x minus 2 squared is 2 right. The minus means right, the plus means left.
Okay. So the phase shift would just be
Pi right. You would say you have to give a direction.
okay.
You have to say pi right, pi left, 2 pi right, 2 pi left. You have to be very, very clear with that. Okay, now the next thing is to figure out how these phase shifts affect this, and that's like a really difficult thing to do as a student. Like this is something you do in trigonometry, and you're not in trigonometry, and you're in pre-calc, but usually they cover this together. So there's an order though. So the first thing we're going to do is we're going to go pi right. Okay, and pi right affects the x values only, just the x values. So you're gonna add pi to everything, to the x values. So the easy ones are the 0, pi, and 2 pi.
Right.
Where it gets more difficult, it's like, what's pi plus pi over 2? Well, think of pi as being 2 pi over 2, which reduces to pi. So when you're adding it to pi over 2, it's 3 pi over 2.
Okay.
And then this is 5 pi over 2 by the same thing there. So the second transformation is horizontal stretch by factor of 3. Now you're going to say it's 1/3. Yes, but when it's inside parentheses, you do the flip of it or the undoing of it. So it's really 1 over 1/3, which is 3. And in terms of like, what are you going to do? You multiply everything by 3. Multiply your x by 3. And I'm really shocked this is being covered in class, but it's 3 pi. Those are these ones, 6 pi, 9 pi. And then the ones in the middle, another thing you can do is figure out what's the midpoint between them. It's 4.5 pi or 9 pi over 2, 7.5 pi or 15 pi over 2. And then you get these numbers. Now we have to do the third shift, and the order matters. You've probably heard me in the past say like the order matters, and you're like it doesn't matter. It does matter. Like it finally matters. Finally get to a problem where it matters. The two on the outside, that affects the y. So the y gets multiplied by 2. So when you're only affecting the y, the x values stay the same. So 0, 2, 0, minus 2, 0.
Okay.
But wait, there's more. Yeah, one more. Down 1. So that last one is down 1. Okay, so that means you're going to take your y's and you're going to subtract 1. Only the y's though, the x's stay the same. Now you can do this, you can do all 4 of these in one step. I don't recommend that. Even I think it's better to break it up at least into a couple of tables or all of them. But now, yay, we've got all our points. We can graph them. So this would be a good place for us to do another one like this. Not any harder, but you know, that you got kind of a crazy difficult one to start with, but we can throw in another one for you to do.
Okay.
All right, so let's say f of x equals sine x and g of x equals 3f 1/2 x. We'll just go minus 2 pi. We won't go crazy on this. Okay, so let's go down the list here. Same order. What is the amplitude?
3.
Actually, yeah, and actually before we do that, you really should write it in terms of sine. You should say, okay, sine 1/2 x minus 2 pi minus 1.
Okay.
Yeah, and the amplitude is absolutely 3. Period. Period is 2 pi over b. You have to remember that b is the number in front of x.
So it'd be 4 pi.
Yes. Phase shift. That's this thing in parentheses here.
Oh. So would it be right 2 pi?
Yes. 2 pi right. Okay, so 2 pi right. What's the next one? Sorry, I was looking for it here. Oh, there it is. Okay. We didn't do that, but let's talk about the table again. So actually the next thing we should do is the list of transformations. Let me grab the function. And again, I'll try and help here because the order does matter. So the first transformation is the phase shift. And you already told me it's 2 pi right.
Yeah.
And I would even go further and say this affects x. That way, when I got to my tables, I knew which one it is. The next one is the horizontal stretch / compress, whichever way it is. This one's really awkward. It's really it's kind of the period, but it's the 1/2. So it's 1 over the 1/2, which is 2.
Mm-hmm.
Now it's a stretch because it's less than 1.
Mm-hmm.
But you say you stretch by a factor of 2, not 1/2.
Okay.
You gotta, and some instructors give you some leniency on that. The third thing is the vertical stretch or compress. That's sorry, this affects x. And in your problem here, it's 3. It's the amplitude. It's not always the amplitude because if it's negative, it is the amplitude. So this affects y.
Mm-hmm.
So notice the stuff on the inside affects x, the stuff on the outside affects y, and then 4 is the shift, the vertical shift, up, down. Okay, so this affects the y.
Okay.
So I'm going to go back and just grab the table here to start with. Okay, so if we look at our phase, the first thing is phase shift 2 pi right. So that means everything in X goes 2 pi to the right. And 2 pi right is really 4 pi over 2 for the ones that don't have the nice, the nice whole numbers.
Right.
But it's also right in the middle of them. So it's 2.5 pi. Now, some instructors are okay with this. I don't really have an opinion. I mean, it doesn't really matter. It really matters if you can graph it, but the table's good. This does not affect the Y, so you just leave it. Got that. So that's number one. That's the phase shift. The horizontal stretch, and that's why you have to do this 1/1/2, because you're literally multiplying them by 2. You're multiplying all of your X values by 2. So that's 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and then the Y's are unchanged. Okay, so the next two affect only the Y. So the vertical stretch of 3, you're going to multiply all your Y's by 3, but your X's don't change. So you just multiply them by 3. It's pretty common to get a lot of zeros. And then the last one is, did I have one? Down 1. Okay, so our Y's are going to go down by 1. So -1, 2, 0, -4, and -1. No, the 0 has to go down by 1 as well. Whoops. Okay, let me grab that. Okay.
Okay.
All right, so now we can get to some of this, and so you would have to graph this last column, and we're gonna hope, we're gonna pray that you get one just like this, and you don't get a cosine. Although I'll give you the table for cosine here at the end to do that. So to find the maximum value of this function could be the max or the min. Okay. So the max or the min, you generally take the absolute value of the amplitude, okay, and you add it or subtract it to the center line. Okay, and that probably doesn't make a whole lot of sense, but let's look at some problems. Let's look at 2 sine, lots of stuff, -1. Okay, so it's either 2 -1 or you take -2 -1. Okay, and I know I said absolute value of the amplitude. I guess I'll change that. I'll change it to it's the a value plus d negative a value plus d. So it's
Okay.
1 or -3. This is obviously the max, and this is the min. And if you go back to your table, you will see that.
Okay.
Like, and I think that's actually easier to look at. It's like, oh, there's the max, it's 2. There's the min, it's -4. If you go back to the previous one, it's like, oh, where's the max? Oh, the max is 2, min is -2.
Right. Oh, okay.
Okay, domain. So the domain is always, 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 always x such that x is an element of the real numbers. So sine and cosine, they oscillate forever. They go in both directions forever. They're always all real numbers.
Right.
So the next one here is range. So your range is the y's. It's the y's such that y is an element of the real numbers, but it's always going to be the following. It's going to be a min less than or equal to y less than or equal to a max. And we've got to come up with those. So we should do another problem here where you have to come up with the min and the max.
Okay.
Okay, so let's do that here. So let's say it's y equals -3 sine of some stuff plus 2. Okay. So you do the following. You do -3 plus 2, and then you switch the sign on the front number. And whatever the up or down is, you either add or subtract it, and you get two numbers here. Whichever one is bigger is the max. Whichever one is smaller is the min. That's your range. Your range is y such that y is an element of the real numbers. -1 less than or equal to y less than or equal to 5.
Okay.
So let me have you try one on your own here. Let's say it's 4 sine stuff -2.
So the min would be a -6 and the max would be 2.
Yes. And we can't tell until we do it which will be which, but yeah, and that tells you your range.
Okay.
All right, so let me give you the table for cosine just in case. Oh, this is where you really, if you knew, we could have an even better lesson. Cosine starts high, comes down, reaches a min, comes back up. So, but the nice thing is that the x values are going to be exactly the same. It's just that the y values change. And you'll learn about that later in the course, I guess. I don't know why they again. Okay. 3 pi over 2 and then 2 pi. So starts high, starts at 1, goes down to 0. Then it goes even further down. -1 comes up to 0 and then comes up again to 1. So this is the cosine one. I don't know if you get a note sheet, put it on there, but we don't know. We don't know what'll be on there. But that's what's key. What's key is that you can have a chance here
Yeah.
for this. All right, so we've got some time left here if we need it. The only thing we haven't covered is that last question, which I just try to avoid it, but we can certainly do that. Is there anything else though on either page that we should clarify?
So the midline would always be like the number on the outside
Yes,
of the
always,
piece.
always,
Okay.
always, always. You don't ever have to like question that. Always, always, always.
Okay. Mm,
Do you see anything else that you think we should cover?
mm, not really.
Which period is your math tomorrow?
It's first period.
Oh God. You don't get to warm up for the day. Just like,
Yeah.
all right, well, I guess the plus side is it's over, first, once you get through it, it's over. If you have time, I would definitely look at your notes. The recording probably won't be up until after you take your test, but the notes I'll send you right away. And if you have time, I would just scan through them and just maybe look for anything that you haven't missed or you're not sure about.
Okay.
But all right. I don't know if we've got any other lessons upcoming. Do you have fall break next week, or is that still further out?
I do have
You
fall
do. That's right.
break.
You told me that you're going to San Diego.
Yeah.
So awesome. Yeah, everybody's got it either this week or next week or it's the week after. So it's great. So enjoy it. You'll come back and you'll have to do more math.
Unfortunately.
Yes. All right, Paige. Well, thanks for letting me help you tonight. And I hope you do well. I think you will. I think you'll have a good test. So
Thank you.
and I'll see you after fall break.
All right. See you then.
Have a great night. Bye now.
Bye.